Okay, we are streaming. Hello out there. So last year, my 6-hour class is who I videoed a lot, and they were so funny. Yeah, we talked about we was gonna sell merch for my channel, and it was funny. Huh? My 6th period last year. Christopher. Yeah. You was in that class last year? With Christopher Ramirez? That's who I remember the most. I thought you were in 7th period last year. It was 6? Okay. All right. Now, today we're going to be talking about complex numbers. Now, a complex number, I'm going to sort of backtrack just a little bit. A complex number is any time that you have a real number. Thanks. Plus an imaginary number.
What does it have on your mark?
I don't know. I bought these at the Dollar Tree, I think. Oh, it does say scent. Sort of blueberry-ish. Okay. So, anytime... Hey, that's enough, y'all. Come on. Anytime you have a real number plus an imaginary number, that's called a complex number. That's what it's called. Complex number. Okay? So, a complex number, we use this to represent a complex number, where A is some plain number, 3, 7, 10, -2, whatever. And B is a number like 2, 5, 8, 1, whatever. And then I stands for the imaginary part of that. Okay? So this is what a complex number looks like. But before we actually do anything with complex numbers, then we need to understand where they come from, or where imaginary numbers come from. So back in, the beginning of time, when dinosaurs were roaming the earth and the caveman was trying to calculate how to get from one place to another, and they were doing square roots, right? So, and I don't know, how much do you know about navigation? Do you know very much? Besides typing it in your phone. Right, so, prior to GPS devices, when people were exploring the world and they were trying to get from one location to another, and they were having to calculate like how to get there and how long it was going to take and how far it would be and all that kind of stuff, one of the things that they used a lot was Pythagorean theorem, right? So a squared plus b squared equals c squared, right? Triangle. They knew that they had this, they were at this location and they wanted to go to this location. So to find out how long it would be, so they could calculate how long it was going to take them to get there, they would calculate this distance based on a squared plus b squared equals c squared, right? So this is one of the things that they did. Now, this is not the only time that Pythagorean theorem was used, but this is one time that it was used a lot. Pythagorean theorem was used a lot in different calculations for different reasons. And what is like your final step of Pythagorean theorem? What's like the last thing you do? You take the square root of something, right? Well, so mathematicians are using Pythagorean theorem and other math things, but Pythagorean theorem specifically, and they're taking square roots of numbers, and so they get like the square root of 4 is 2, right? And they get like the square root of 36 is 6, and various things, because we know that square root means what number times itself makes that number, right? Now I'm going to backtrack just a little bit. What number times itself is 4? Is that the only option? So, when we say, back when you were, do y'all remember when you learned about square roots the first time? Do you know how old you were? Like, I'm thinking like 6th, 7th grade maybe. When you learned about square roots the first time. When they teach you about square roots to start with, they don't go into this because they don't want to scare you because you don't really know much about negative numbers yet. But when we take the square root of a number, it's not just the positive value that is that answer. The other option is the negative value because a negative times a negative still gets you that number, right? -2 times -2 is 4. So when we say the square root of 4 is 2, it's really positive or -2. And that's how we would write that, positive or -2. And we're going to be using that a lot here in the very near future, okay? But it's also something that you need to know for what we're going to do today. Anyway, back to what we were talking about. So they're doing these, they're taking square roots and they're getting answers, and then they get something like this. What number times itself would give me -49? Why not? 49 is not a prime number. Okay, so the only way that you can get the number -49 is if you multiply a positive times a negative, right? And if you're multiplying a positive times a negative, those are not the same number. Those are two different numbers, right? So at first they would just be like, this is impossible. I can't do this. I can't take the square root of this negative number. And then somebody, and I don't even know who it was, but somebody was like, you know what? What if we took part of this, the negative part of this, and we call it an imaginary number? Okay, so what if we take part of this and call it an imaginary number, and then we can take the square root of the 49. So here's what they did. They broke up this -49 into 49 times -1. Now, when you're taking the square root of things or you're multiplying things and then square rooting them, it doesn't matter the order. So, for example, what is the square root of 4 times the square root of 36? So what is the square root of 4? And what is the square root of 36? And if we multiply them together, we get 12. But if I take the square root of 4, and if I do 4 times 36, somebody do that for me. And what is the square root of 144? 12. So, see how it doesn't matter whether we multiply first or take the square root first, we'll still get the same answer. So they said, okay. So, if I take the square root of 49, right, and the square root of -1, this I can do. The square root of 49 is 7. This, we're going to call that the imaginary number I. And so now, instead of saying I can't do this, now I'm going to say, oh, that's 7i. That's an imaginary number. Y'all with me so far? Everybody good so far? Okay, so anytime you have a negative value under your radical, you can take that number and break it into its form times -1. So like, for example, the square root of -9. We can break this up into the square root of 9 times -1, which is the same thing as the square root of 9 times the square root of -1. Now, what is the square root of 9? 3. And just as a reminder, technically it is positive or negative 3, right? And then what's the square root of negative 1? I. So that's the positive or negative 3i. Y'all with me? Yes. If it's a negative value. Okay? So you always just pull out negative 1. Now, if it's not a perfect square, there's some different circumstances, but we're not going to do that today. Today we're just going to focus on some perfect square stuff, okay? Just to make what we're about to do a lot easier. All right. Everybody good so far? Now, do we have to go through all of these steps? No, of course not. So like 81. Let's say we have the square root of negative 81. You know the negative is going to be the I part. And then the 81 is, what's the square root of that? So we know it's actually positive or negative 9i, right? Okay. Are we good on this part? Okay. All right. Now, this next part is where people really sort of struggle to grasp it at first. But once you get it, it's super simple, okay? So, we just come up with, or I just taught you, that the square root of negative 1 is I. Right? Now, if I take I and I multiply it times I, now, how could I write that? I squared. So what we're talking about right now is I squared. Okay? We know that I represents the square root of negative 1. Right? And we know that it doesn't matter when we're square rooting and multiplying if we square root first or we multiply first, right? Y'all with me so far? Are you? Is there something really that you have a question about? No. They're just being jerks? Yeah. Okay. He was yelling very quietly. Yeah. Okay. Because he equals what he said. All right, let's back up. Let's go back to this right here, right? So we've got the square root of negative 1 times negative 1. Now, if we multiply that, what do we get? 1. What's the square root of 1? Or negative 1. Now, if you're given no context, then you would say 1, right? Given no context about a number, you would say 1. However, remember, square root means what number times itself. And what number is being multiplied times itself right here? Negative 1. So if we take the square root of negative 1 times negative 1, we get negative 1. Because that's what number is being multiplied times itself. That number right there. Do you understand what I'm saying? So here's what we just discovered. I squared is equal to negative 1. So if you have I squared in a problem, you can replace that I squared with a negative 1. Okay? So far? Making sense? All right. Now what if we do I times I times I, which is the same thing as I cubed. Now, we can replace 2 of these with negative 1 because 2 of them is I squared, right? So we can replace the 2 of them with negative 1, and then the other one, we can just leave it as I. So I cubed is equal to negative 1I, or just negative I. Y'all good so far? Okay. That's what I was saying earlier. This that we're doing right now is the hardest part about what we're doing. But once you get this, you're going to go, oh, I gotcha. I'm gonna trust you on that. Okay. Right here. I times I times I cubed. If I just use 2 of them, that's I squared. What did we just figure out I squared equaled? -1. So I'm going to replace the I squared with -1. Because I squared equals -1. Okay? So all I did was replace the I squared component with -1. The I is still there. That single I. So -1 times I would be -1I. But we don't need the 1, so we can just write -I. Do y'all have a problem with my I?
Yeah.
Leave my I alone. I got a little wild with the tail, okay? Okay. You good now? Okay. Everybody else good now? So that was I cubed, right? I cubed. Now, what if we do I times I times I times I? Y'all reminded me of those yip yips on Sesame Street. Yip, 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 yip. Y'all know what I'm talking about? I don't like SpongeBob. Okay. You are right. Now let's get the rest of the class on board, okay? Where are they getting 1? Like, where is 1 coming from? I times I squared, -1. I times I squared, -1. What's -1 times -1? +1. So I to the 4th power is equal to 1. I don't know.
So I to the 5th equals
I to the 5th equals I.
That makes no sense.
Okay. Okay. So Landon,
What does this do?
we're getting there. Hold your horses, sir. Hold your horses. Okay. Landon has already figured out the pattern here. Okay? So what is I'm going to tell your mama it's you. I to the 5th is equal to I to the 4th times I, right? And what do we know I to the 4th equals? 1. So that's 1 times I, which is just I.
What about I to the 8th?
No. So let's say we did I to the 6th, right? So we could break I to the 6th down into I to the 4th and I to the 2nd, right? Now we could break it down into like 3 and 1, but that doesn't make sense, right? 4 is equal to 1. I squared is equal to -1. So what is this? -1. I to the 7th. So that's going to be I to the 4th, right? Times I to the 3rd, right? Now what do we know about I to the 4th? It's 1. Technically we can just be like, oh, it's gone, right? Because it's just a 1. And anytime you multiply by 1, you just get what you're multiplying by that number. And then what do we know about I cubed out of the 3rd? What do we discover it is? It's -I. Right? And then if we did I to the 8th, how could we break that down?
2 i's.
Which are equal to what?
And 1 times 1.
1 times 1, which is 1.
It's a series of ones and I.
It is a series of 1s and i's. It actually rolls out like this. So, we start with I is our first one, right? And then I squared is equal to -1. And I to the third power is equal to -I. And then I to the fourth power is equal to 1. And then we just start all over again. I to the fifth power is I, right? I to the sixth power is -1.
This looks too much like computer code.
I to the seventh power is -I. I to the eighth power is 1, right? What would I to the ninth power be? Now let's make it easy.
Wait, what if? Yeah, no.
I can't take it.
I don't care. I dare you. Don't do it. Don't do it. Don't do it. Okay. All right. So let's make it simple. Okay. You need to know I squared, I cubed, I to the fourth. Right? So I, of course, is I. I squared is -1. I cubed is -I. And I to the fourth power is +1. And if you know those four, that's all you got to know. Right. How do you figure it out? Well, let's say you have I to the, pick a random number, somebody. 34. So all we have to do to figure out what I to the 34th power is take that 34 and divide by 4. Now, and we're not going to get a decimal. We're using remainder. So 4 goes into 34 how many times? 8. 8 times 4 is 32, right? And we have 2 left over. So I to the 34 is equivalent to I squared, because 8 times 4 is 32, and if we take 32 out of 34, we have 2 left over. And what do we know I squared is? -1. I won't. I'll wait right there for you. Yeah. At the end of school last year, remember we did review over stuff that I felt like you would need to know for geometry? I mean, for Algebra 2. This was one of them. Yeah, this we did not get very deep into. Not very deep at all. I just wanted y'all to have seen it before. Okay. Jordan, you good? Okay. And I'm going to be straight up with you. What do you really, really, really need to know? Well, and I mean this one, but that one's simple, right? You really need to know I squared, and you really need to know I to the fourth. Those are your two really important ones. I mean, you do, but it's not going to be as, you're not going to see it as much. You're just not. Just based on what we do mathematically, you're just not going to see it as much as you'll see these other two. Okay. Time check? Somebody? Okay, I'm going to stop and give you the last 13 minutes just to work on those problems from yesterday if you didn't finish them. And then we'll pick this up again tomorrow, okay?